Hello everyone. Today we will explore the fundamental concepts of force system. This is a vital topic in mechanics, foundational to understanding how forces interact with objects. I am Dr. Atrayee Bandyopadhyay, Assistant Professor of Department of Civil Engineering, Haldia Institute of Technology, and I will guide you through the key concepts and classifications that define force system. Now, what is force? So let us begin with the definition of force. A force is an agent that produces or tends to produce or destroys or tends to destroy the motion of a body. It is a vector quantity, obviously, so it will have at least magnitude and direction as its characteristics. Other than that, force have also other two characteristics, that is nature, that is whether the force is tensile or compressive. And the fourth one is point of application, that is the specific point where the force acts. Mainly the unit of force is Newton. Now, what are the types of forces? Forces can be categorized based on their nature and mode of application, like contact force, body force, point force, distributed force, external and internal force, frictional force, wind force, hydrostatic force, cohesive and adhesive force. Among these forces, few of them are already known to you. Let us learn what all these forces are. Now let us come to contact force. What is a contact force? Contact force is a type of force that is produced by direct contact of bodies, and it is known as contact force, and it may be of either pull type or also of push type. When we stand on a floor, the weight of the body or weight of the human is exerted on the floor. Similarly, the floor exerts a reaction, that is the contact force that is exerted on the human body. This is an example of contact force. Now, body force. Forces produced without contact of the bodies is called body force. That means it is the force that holds together the particles forming the rigid body. Two different body does not acting here. It is the force that is generated inside the body to keep the particles of a body together. Now let us come to point force. Point force is a force acting at a point. That is why it is called point force. It acts on a very small area compared to the total surface area. We can give an example of this, like if a nail is stuck on a wooden plank and if we are trying to get the nail out of the plank using a hammer, that is using the hammer, if we pull the nail from that wooden beam, a wooden plank, what does that signify? It signifies that the nail has been tried to pull out from the plank. That is the force that is exerted on the nail, uh, on the direction outside the wooden plank, is acting on that point of the nail where it is inserted. That is the force that is used to take the nail out of the wooden plank is concentrated on that point. That is why this type of force is a good example of point force. Similarly, we can also see that what is an example of distributed force from this picture. What is distributed force? When force is distributed over the large area, it is called distributed force. Like you can see in the image here, when a balloon is pressed on so many of a bed of nails, it doesn't rupture easily. But if you uh, push a pin through that balloon, it will burst immediately. So the force that is applied on a point force will burst the balloon, but whereas the force is distributed through the nails in this picture, what you can see in the slide, it is called distributed force, and the force is distributed among all the nails while applying on the balloon. Now, external and internal force. The force exerted by weight on a body is external force, while the resistance offered to retain its shape is called internal force. That is, when a body is pressed or squeezed, the body always tries to maintain its original shape. That is why the stress or squeeze or force that is exerted on that body is always being tried to balance out from the stress generated inside that body to maintain its shape. The external force is applied outside from outside, and the stress generated inside that body is the internal force. Action and reaction. As per Newton's third law, we all know whenever a body exerts force, that is an action on another body, the other body exerts similar force on the former body known as reaction. That is, every force have equal and opposite reaction. We can see some example of that phenomena here. That is when a human is unboarding from a ship towards the land, it pushes the boat through his legs, for which the body of that human moves forward and reaches the land, and the boat moves backward. That is a very good example of action and reaction. Similarly, in the balloon, if the balloon is kept open, air-filled balloon is kept open, then the air rushes down through the outlet of that balloon, and in the reaction, the balloon goes up. Frictional force. It is a very important force. Excuse me. Frictional force. What is the frictional force? Resisting force offered during sliding of a body by the surface in contact is called frictional force. That is, if a body is placed on a surface and it is pushed or pulled by sliding the body on that surface, then towards the motion of the body, the force that is pushing or pulling is acting, and in the opposite direction of the applied force, that is, when the motion is in this direction, then the friction is always in the opposite direction of the motion. Now, what is wind force? Force exerted by wind when it is obstructed by any object. You can see while some of us have experienced a tornado or some gust of wind, that when a wind blows in high velocity, the thin trees tends to bend towards in the direction of the wind force. That is a good example of wind force. Hydrostatic force. What is an hydrostatic force? The force exerted by water on a body when it is obstructed by a body. We can see a good example of this in a dam. In a dam, the water is stored in a huge amount, and on the dam wall, when the water is stored, the water is exerting a pressure on that wall. Like this, we can give also a simple example also. If there is a bucket where there is water is stored, if you make a hole in the bucket, the water will flow out. But if you make a hole in the upward side of the bucket, the hole that through the water is going out will have lower reach. But when you give a hole in the lower side of the bucket, the water will flow more swiftly or more forcefully. That is because the depth of the water is increased. That's why the force is also increased. Then the water, when a water is stored in a body or in a when a water is obstructed or stored in a body, the water exerts a force on the wall also. This is called hydrostatic force. Now, cohesive and adhesive forces. Forces developed between molecules of same material is called cohesive, and forces developed between molecules of different material is called adhesive forces. That is when a body that is consisting of same materials, the molecules of that body exerts a force onto each other. That is called cohesion. And when two different materials in a body is exerting force on each other, that is adhesion. Now, consisting of these forces, when two or more forces acts on a body, they are yet to form a system of forces. These forces can be classified based on the geometry and interaction, like coplanar forces, concurrent forces, collinear forces, coplanar concurrent forces, coplanar non-concurrent forces, non-coplanar concurrent forces, non-coplanar non-concurrent forces, parallel forces that can be of like and unlike type, and spatial forces. Let us go through these type of forces in details. Now, what is a coplanar force? Forces whose line of action lie on the same plane are known as coplanar force. That means when three forces acting on the same plane That is known as coplanar forces. That means in a same plane, whenever how many forces are acting does not matter, but when the forces are acting on that same plane, all the forces will be called as coplanar forces. Now concurrent forces. The forces which meet at one point are known as concurrent forces. Means if three forces or forces, any number of forces are going through a same point in their line of action, that all forces are known as concurrent forces. It is not necessarily that the concurrent forces must be in a same plane. So for only the title of concurrent forces, any type of forces that goes through a single point is known as concurrent forces. Now collinear forces. The forces whose line of action lie on the same line are known as collinear forces. That means if two or more than forces are acting on a same line, that is their line of action lies on the same line, then it is called collinear forces. Coplanar concurrent forces. Forces which meet at one point and lines of action also lies on the same plane are known as coplanar concurrent forces. We already know what is coplanar forces. We already know what is concurrent forces. So coplanar concurrent forces are nothing but the coplanar forces that are concurrent. That is the forces that are acting on the same plane and also goes through the same point. Which line of action goes through the same point is known as coplanar concurrent forces. Now, coplanar non-concurrent forces. From the title, it is already can be understand. Coplanar means all the forces will be in a same plane, but non-concurrent means the forces will not go through the same point. The forces whose line of action lies on the same plane, but they do not meet at one point, are known as coplanar concurrent forces. Here are the examples of such forces. You can see from the image. Excuse me. Non-coplanar concurrent forces. Forces whose line of action do not lie on the same plane, but they meet at one point. Those forces are known as non-coplanar concurrent forces. As it is titled in the name has already the word non-coplanar. It already signifies that the forces that will be in this category will not be in a same plane. But it also has the title that concurrent. That means all the forces, no matter which plane it will go through the same point. Therefore, from the image we can see three forces are in different planes but goes through the same point of the origin. That is non-coplanar concurrent forces. Similarly, non-coplanar non-concurrent forces. The forces whose line of action neither lie on the same plane nor do they meet at any point. That means these forces are not at all connected in any way. That is not in the same plane. Neither their line of actions are going through the same point. Okay. So these type of forces are known as non-coplanar non-concurrent forces. Now parallel forces are of two types, like parallel and unlike parallel. From the word parallel forces, it is already clear that the forces that are parallel to each other are known as parallel forces, and like parallel forces means forces whose line of action are parallel to each other and all of them act in the same direction. Those are called like parallel forces. And forces whose line of action are parallel to each other but all of them do not act in the same direction are called unlike parallel forces. You can see from the images also. Now spatial forces. Forces acting in the space are known as spatial forces. That is in a 3D. You have to image in 3D now. Forces acting in the space but meeting at one point are known as spatial concurrent forces. Obviously, concurrent forces means the forces that are acting through a single point, and when it is in the space, that is known as spatial concurrent forces. Now, application of forces. Why do we are learning this force system? Because understanding force system is essential in designing and analyzing structures, predicting material behavior, and ensuring stability in various engineering fields. Now, conclusion. Why are we learning this? To summarize, force system that are building blocks of mechanisms essential in understanding the interactions between objects and forces. Whether we deal with simple forces like friction or complex systems like spatial forces, Mastering this concept is very crucial for any engineer. So let us end here. And if you have any query, please let me know in the comments. Thank you.